Video, we're going to talk about exponential growth versus decay. Specifically, we're looking at how we can tell if an equation is going to be growing exponentially or if an equation is going to be decaying exponentially. To introduce this idea, what we're going to do is we're going to graph a few equations and then we're going to talk about growth versus decay. So when we graph the first equation here, I have y equals 3 times 2 to the x. Remember that this first number, the 3, is our starting value. So when x is 0, we know we're starting at 3. The second number is what we're multiplying by every time we jump down the table. So as I jump to the next box, I times by 2. Well, 3 times 2 is 6. And then I times that number by 2, and I get 12. And I times by 2 one more time, and I get 24. I then can plot these points on the graph. So I have the point 0, 3. So 1, 2, 3. Put my first point there. 1, 6. Put a point there. And 2, 12. Okay. Then 324 I'm not going to worry about because it'll fly off my graph. Also recall that exponential functions, okay, if I were to go to the negative side of my graph and look at the negative values, remember that instead of timesing by 2, I would end up dividing by 2. And when I take 3 divided by 2, I get 1.5. Okay, and then I would take half of that and half of that and half of that. And it's important to remember this will not reach 0. Okay, it'll end up trailing off like this. Okay, we call this exponential growth. Okay, so this is a graph of growth. The reason why we say it's exponential growth because as the x's on my x-axis get bigger, okay, or more positive, the graph grows, it goes up. You can see this in the chart as well. We started at 3, then 6, then 12, then 24. We're growing, so it's exponential growth. If we look at the second one, here I have y equals 4 times 1/2 to the x power. Once again, the 4 represents our starting value, so I'm starting with 4. And then the 1/2 is what I'm multiplying by every time I move down the table. So 4 times 1/2 is 2, 2 times 1/2 is 1, and then half of 1 is 0.5. So if I graph these, I'm starting at a height of 4, at 1, I'm at 2, at 2, I'm at 1, and at 3, I'm at a half. Once again, you'll notice it's curving, and this time it's trailing off towards the x-axis over here. You can probably guess, we call this exponential decay. We call it decay because as the x's grow, the line slopes down. It's getting smaller and smaller and smaller and smaller, but it's not approaching, or it's approaching 0, but it never reaches it. Now, if we look at our table, we can see this as well. We started at 4, then we had 2, then we had 1, then we had 0.5, then we come 0.25, and so forth, and the numbers would start decaying. They're slowly getting smaller and smaller and smaller. Now, ideally, we don't want to have to do all of this work to know if the function is going to grow or if the function is going to decay. We can actually tell by just simply looking at the equation. You can probably guess, but the number or thing that controls growth or decay is your multiplier. Okay, it's what's inside this parentheses right now. It's what we're multiplying by down the table. If it is a fraction that's less than 1 but greater than 0, the thing is going to decay. Okay, so like a half or a fourth or a third. Any numbers, okay, I'm going to call them multiplier, M for multiplier. Any numbers that are less than 1 but greater than 0 is going to decay. Okay, any numbers greater than 1, okay, will grow. Okay, so 2, 3, 1.5, any numbers bigger than 1, we're going to see growth. Any numbers less than 1, we'll see decay. Now, continuing on, we're going to graph one more function here. And this is going to help us to see how much something's growing. So here I have y equals 2 times 1 to the x. Now, notice my starting value is a 2. And this time I'm multiplying by 1 as I move down the table. Well, if I take anything times 1, so 2 times 1, I would get 2. Well, if I take 2 times 1 again, I get another 2. And if I take 2 times 1 again, I get another 2. Notice that I'm always going to get 2's. So on my graph, I always have a value of 2. For any x value that I plug in, I'm always going to be at 2. This function is neither growing nor decaying. In fact, it's actually not an exponential function. If I take 1 to any power, that's really just 1. And 1 times 2 is equal to 2. So this equation is really just y equals 2. It's actually a linear equation. But it helps us see something important about growth or decay. When I have a 1 as a multiplier, or as my m I'm calling it, notice there's neither growth or decay. It's like the balance point. It's like the neutral point where I don't grow nor decay. If I'm bigger than 1, as we saw in the first example, when I was bigger than 1, I was 2, we saw it growing. When I was less than 1, we saw it decaying. When it was a 1, it's not an exponential function, it's actually linear, and we don't see growth or decay. Now, this is useful because we get questions that ask us how much something is growing or decaying. So it says, is the function growing or decaying, and by how much? So let's look at 2 examples here. In A, I look at my multiplier, the thing that I'm multiplying by, and I ask myself, is that bigger than 1? Well, it's 1.33, which is greater than 1, so yes, I know this is going to be growing. Now, it also wants me to know by how much. This is where the 1 comes in handy. I know it doesn't grow or decay when I'm at a 1 value. So all I have to do is figure out how far is this number from 1. To do that, I simply just minus 1 from that number. Notice 1.33 minus 1 gives me 0.33. And then if I take 0.33 and switch it to a percentage by multiplying by 100, I'll see that this is growing 33%. Yeah, let's look at one more example, and this one we'll do a decay example. So here, I'm still looking at the multiplier. This time, I see that the number is less than 1, so I know it's going to be a decaying function. It's going to slope downwards. And if I want to know how much, I subtract 1 just like I did before. And I'm subtracting a 1 because 1 is where the balance point is. Now, if I do this, I get negative 0.03. Now, normally when we're talking about the percentage rate, we don't necessarily care as much as about the negative. What the negative's telling us is that's just re-emphasizing the fact that this function is decaying. What we really care about is this number, okay, the 0.03. We times by 100, which switches it to a percentage, and we see that we're decaying by 3%. Okay, so just some things to recap here shortly. Exponential growth will always curve upwards. Exponential decay will curve downwards. If you are looking at a function and you want to know how much exponential growth or decay there is, you simply take the multiplier, you minus 1, times that number by 100, and it will tell you the percentage of growth or decay that will occur.